Morning everyone. I am Dr. Dilip Singh from Jagran Lake City University, Bhopal, and today we are going to have a session on segmentation. So let's start. So basically, segmentation is another technique of non-contiguous memory allocation, right? And you know, under the non-contiguous memory allocation, we already had a discussion over one of the very famous technique called paging in the last session, right? And the biggest problem with the paging technique was that it doesn't consider the user's view of the process while dividing the process into the fixed size pages, right? And now what is user's view means how user um, think the process is look like, right? So generally the user think or visualize the process as it is divided into the procedure, functions or methods, data, object, stacks, array, right? So this is how the users think. But in case of paging, it's not divided in this way, the way the user think. In paging, it is divided into the fixed size of partitions, we can say, that is called pages, right? So what is segmentation? So we can say that the whole program or a process is a collection of segments, and segments are the logical unit of a process, right? Such as procedure, function, method, data, object, stacks, array, symbol table, common subroutines, right? So these are some logical units of any process. So these logical units of the process are called segmentations, right? So a segment is nothing but a logical unit of any process. So these such as the main program, procedure, function, and all. So the concept of segmentation is what? The whole process or program is divided into the segments, and segment is nothing but this logical unit of a programs that can be of function, method, object, common block, stack, symbol table, array, right? So how we can see uh, this is how is we can imagine or visualize, or this is what the users perspective or view of a program that segment support. Means the whole program is divided into the various logical units that can be a subroutine, stack, symbol table, main program, or functions such as square root, right? Correct. So whole program is divided into the segments, right? And so yes, of course, now we can say that segments support the user's view of a process. So we store different segment as a whole in the main memory, right? And so the different segments may store at the different places of the memory. So as the segments are distributed throughout the memory, so we need to keep track of his segment information, right? It's the same as we were keeping the information in case of paging with the help of page table, right? In the same way, we'll keep this addressing information of each segment into the segment table. So in case of paging technique, we were using page table. Now in case of segmentation, we are using segment table to keep track of what the address related information of each segment, right? So this is how, again, we can think, this is how the whole process is divided into various segments, can be 1, 2, 3, 4, these 4 segments for example, this process is divided into 4 segments, and in a physical memory, these 4 segments would be, stored somewhere wherever they got the space. For example, the first segment and the fourth one is stored here, and the second and the third segments are stored in this place somewhere in the main memory or physical memory, right? And so each segments we can refer by a segment number. And of course, there is no need that every segment should be have of same size. So every segment may have a different size, correct? And each segment allocated to a contiguous block of memory. Although segmentation is not contiguous. Why? Because different segment may be stored in a different place of memory, but one particular segment should be stored in a one contiguous block of memory, right? And the logical address for this whole is divided into two tuple. The one is a segment number and the another one is offset. So the concept is same as in a paging. The logical address were divided into page number and then the its offset. So in case of segmentation, it's divided into the segment number and the offset, right? And the segment table, basically what information the segment table will have. So in case of paging, the page table were having the information of the frame where the particular page stored, right? So in the same way, in case of segmentation, the segment table will hold the information of every segment where that segment is stored in a main memory. So segment table will be used to map what that two-dimensional physical address, correct? This two-dimensional physical address. So segment table will having the various entries, and each entry will be of divided into these two parts. The one is the base address and the limit, correct? So each table entry will have the base address and the limit. So basically the base address, it's the same way as we had a discussion in the previous sessions. So base address will contain the starting physical address where the segment, reside in a memory, or segment is loaded in a main memory or stored in a main memory. That is starting physical address, is a base address for that particular segment, right? And the limit is specify the length of that segment, correct? The size of the segment, right? So for the point of implementation point of view, so the segment table base register will be used to point the segment table location in a main memory, and segment table length register indicate the number of segment used by the program, of course, right? So like in the same way, in a paging, we in a page table there were various other fields for the protection and all, right? In the same way, segment table may also have the various fields like the protection dates, illegal segments, right? And even the each segment may have associated some privileged, like the read, write, or execute privilege. This granted to that particular segment, so not, right? So segment, let's see the example or the segmentation hardware. So it's quite similar to the paging hardware. A small difference is like this. The CPU generally used to generate, of course, the logical address. So, and here in this case, the logical address will be divided into the two part. The first part is a segment number. The first part will be used to identify the particular segment number in the segment table. So the first part, as here, will act as an index for the segment table, and whereas the second part of the logical address will be the offset. right? So from the first part, from the segment number, we'll go to the segment table and we'll see the base address for that particular segment, right? And we'll take the base address from this segment table. But before taking the base address, we'll cross check with the limit, right? So the offset should always be less than the size of that segment or the limit of the segment. If the offset is not less than the limit of the segment, then that trap and addressing error will generate. Why addressing error? Because maybe that CPU is trying to access the location of some different segments, because this segment limit is not, this offset is not less than the limit of this semester. It's beyond the limit of that semester, maybe trying to access the address space of some other segments, right? So that we need that to protect, right? That should be protected. Means the CPU should not, the one process uh, should not be able to, interfere with the address space of another process of the segments, right? Correct. So if the offset is less than the limit, then the things are fine. And on that case, the base address for that particular segment will be taken from the segment table, and the base address will be added with to the offset to generate the physical address. And the physical address will be generated, and with that, with the help of that physical address, of course, we can access the instruction or a particular data for which the CPU has generated that logical address. Right, so this is how this segmentation hardware will work. So this is an example, and so let's take an example. This is the example, and we'll take another one. Just a minute. Yeah. So suppose we are having one process, and the process is divided into 5 segments, suppose, of different size: S1, S2, S3, S0, S4, right? So this is one process, and the process is divided into various segments, 5 segments. And this is the main memory or physical memory, right? So main memory, this is how the process is, stored or loaded into the main memory. So every segments are there, suppose, in the main memory, for the sake of this example. So a main memory addressing will start maybe from 0 to 500, and suppose the operating system is there in this particular, address space. And then from the the address 500, which segment is stored? S4. And maybe 1000 nothing, then S2 is stored somewhere, the address is started from 1200, and S0 segment is stored somewhere, from the address is started 1500, S1 is stored. So this is how all the segments are stored in a main memory, suppose. Now the segment table, how the segment table will look like for this particular example, right? So this is the segment table for this case, correct? So for this process, this is the segment table, where what is the information? The segment table will keep the information for each segments, what? The base address and the limit. This is limit, the base address and limit, correct? The base address and limit, right? So for example, S0 is the segment S0. So S0 is stored in a main memory in which place? Here. So starting physical address of S0 is 1500. So the base address for the segment S0 will be 1500. And what is the limit of S0? So size of S0. So S0 is started 1500, and it's stored up to 2700. So the size of S0, 2700 minus 1500. So what would be there? 1200. So this is the 1200 size of the segment 0. In the same way, S1 is stored from which physical address? 3000. So this 3000 will become a base address for segment S1, and the length or the size of S1 is, S1 is stored till 3800. So 3800 minus 3000, it's 800. Correct. So in the same way, all the segments are stored, and this is how the page table is created. So page table, this is how the segment table is created. So in this, within the segment tables, you can see segment table will store what kind of information? The base address and the limit for the each segment stored in a main memory. Correct. And now suppose CPU generated some logical address to access a particular instruction or a data from a physical memory. So in order to access a data or instruction from physical memory, there is a need of conversion from logical address to the physical address, because CPU always generate a logical address. So this is how the logical address generated by CPU, suppose. So the logical address would be divided into two parts as it is, so the first part will be treated as a segment number, and the second part would be the offset, right? So with the help of segment number, we can, go for which segment the CPU want to access, or the CPU want to access the instruction or data that is inside the which segment, right? So that we will identify with the help of this field of bits, segment number. So suppose this is suppose 0 0 1 0. Suppose this is, least significant 4 bits are representing the, suppose for this example, representing the least significant 4 bit are representing what? Segment number, suppose. So 0010 means which segment number? 2. This one. Which segment number? 2. Correct. So suppose segment number 2, the CPU want to access, and the offset is D. Then how it will work? In the same way as we had a discussion over the PPT, the hardware, segmentation hardware, the offset will go from here to here, and from this segment number 2 will take the limit 300. So we'll check whether the offset is less than the limit or not, right? Because if we want to access the data from segment number 2, this is the segment number 2, right? And we know that segment number 2 limit is 300, 1200 to 1500, 300. So offset would be within 1200 to 1500 only, right? So the offset should always be less than the limit, right? So D always should be less than this limit, right? If yes, offset is less than limit, then fine, we can go and calculate the physical address. But if offset is not less than limit, means offset is beyond the limit and maybe trying to access the address space of some another segment or another process, so that should be protected. And that's why if that case will rise, then there would be a trap to operating system. Operating system will take over and may generate the addressing error, right? And the CPU will not be able to access that particular instruction or data in that case. But if the things are fine, offset is less than the limit, then we'll take a offset, right? And from here we'll take a base address of this second segment, and we'll add, and then we can find out, after this addition we will find out the physical address. So suppose if all these addresses are represented in decimal number, like here, for the just sake of example, then how the things are calculated? So if the logical address is 2, 25, so 2 is what? The segment number, and 25 is offset. So how the things are generated? What will be the physical address for this case? So 2 means segment number 2. So we'll go to the segment number 2. Base address is 1200 and limit. But before calculating the physical address, we have to check the limit, which is 25, should not be greater than or another word we can say, the limit should be less than this offset should be less than the limit. So limit is 300, offset is 25. Yes, it is less than, so not an issue. So how it will be generated? We'll add the offset with a base. So 1225. So answer would be 1225 in this case. Answer would be 1225 in this case, right? So 1225 means CPU has generated the logical address to access which instruction, which is stored in physical memory at what address? 1225 actually. So in S2, this is the S2, 1225 maybe the instruction may be stored somewhere here, right? And then the CPU will easily access it, because now CPU now through memory management, now the system know the address, exact address of that instruction of data to which CPU want to access. Correct. So this is how it works. Let's take another example, 4 and 230. So segment number 4, this limit is 500. So 230 is less than 500. Correct. So we can go and base address is 500, S4 is in 500. So 500 base plus 230. So its physical address would be 730. Correct. Its physical address would be 730. It's very simple, right? And now the another case, 0 and 1423. So 0 is segment number 0. Segment number 0 is stored in, let's see, base address is 1500 and limit is 1200. But offset is 1423. So if limit is 1200 and we are trying to access 1423, means offset is more than the limit. So what would be the physical address? Nothing, but there would be a error and the system will be trapped, right? So there would be a trap and addressing error. Correct. And in case of this 3 and 10, so 3 is a segment number 3, base address is 4000 and its limit is you can see here 1000. So 10 is less than 1000, so not an issue. So the answer would be 40 and 10 would be its physical address, because we will add base address with a offset. Correct. So this is how it works. This is how the segmentation works. Hope the concept is clear. So let's go back to the PowerPoint. And yes, that's done. This is another example for the same, right? And before closing the session, we can say although as compared to the contiguous memory location, there is not a the external fragmentation that was there in case of contiguous memory location, right? But some sort of uh, we can say that segmentation, there is a chance of external fragmentation. Maybe it cannot be as weird as we have seen in the case of contiguous memory location, but of course in a small amount event, but there is a chance of external fragmentation in case of segmentation, right? And so so let's see, the fragmentation is a vestige of memory. So in case of in paging, there were a internal fragmentation. The drawback was internal fragmentation. In case of segmentation, the drawback is a small amount of external fragmentation, right? So there is another concept where we can merge the advantage of paging and segmentation, right? And the new techniques were, that is called paging with segmentation, where the advantage of both paging and segmentation were merged, right? So that paging with segmentation, which is also called segmented paging, right? So in this technique, the whole process maybe can be divided into a segment, and further, the each segment can be divided into the pages. So that concept would be, segmented paging or paging with segmentations. So that would be the another technique of non-contiguous memory location. Correct? Okay, so thank you and bye bye.